On December 26, 2024, China conducted the first test flight of its sixth-generation fighter jet, the Chengdu J-36, marking a significant milestone in the global race for advanced military aviation technology. Developed by the Chengdu Aircraft Corporation (CAC), the J-36 is poised to enhance the capabilities of the People's Liberation Army (PLA) Air Force significantly. With its cutting-edge design and advanced technologies, the J-36 has captured the attention of military analysts worldwide. This article provides a detailed examination of the J-36's design, capabilities, potential roles, and its impact on global military aviation competition. The J-36's maiden test flight took place on December 26, 2024, at CAC's airfield in Chengdu, Sichuan Province, accompanied by a two-seat J-20S chase plane. The event garnered significant attention as images and videos circulated on Chinese social media, sparking widespread discussion among global military observers. While the Chinese government has not issued official statements, the lack of censorship on these leaks suggests a deliberate effort to showcase the aircraft's capabilities to an international audience. In March 2025, Chinese state media dubbed the J-36 the ginkgo leaf jet, due to its resemblance to a ginkgo leaf, further fueling public interest. On April 7, 2025, a video captured the J-36 flying low over a highway in Chengdu, preparing to land at the airfield, providing clearer insights into its design and performance. These test flights, primarily conducted around Chengdu, have focused on evaluating the aircraft's flight control systems, engine performance, and stealth capabilities, underscoring China's rapid advancements in aviation technology. The J-36 features a distinctive tailless design with delta-shaped wings, optimized for stealth by minimizing its radar cross-section. The aircraft is estimated to be approximately 22.86 meters long with a wingspan of about 20 meters. Its weight ranges from 99,200 to 119,000 pounds, making it larger and heavier than its predecessor, the J-20. The aircraft is powered by 3 engines, with 2 ventral air intakes for the lower engines and a dorsal intake for the third. These engines are believed to be WS-10C or WS-15 models, potentially incorporating advanced adaptive cycle engine technology. This configuration enables high-speed supercruise capabilities and an extended operational range, positioning the J-36 as a formidable platform for long-range missions. A key feature of the J-36 is its internal weapons bays, which include a central bay beneath the fuselage and 2 smaller side bays. These allow the aircraft to carry long-range missiles and other munitions while maintaining its stealth profile. The airframe, constructed from advanced carbon fiber and high-grade alloys, enhances aerodynamic performance and further reduces radar detectability. The J-36's cockpit adopts a side-by-side seating arrangement for 2 pilots, a design more commonly seen in bombers like the F-111 or Su-34 than in traditional fighters. This configuration facilitates enhanced coordination between pilots, making it suitable for complex missions requiring precise teamwork. Additionally, the J-36 is equipped with advanced sensor and communication systems, including active electronically scanned array (AESA) radar, infrared search and track (IRST) systems, and data links for integration with drones and other aircraft. These systems enable a system of systems approach, enhancing operational efficiency in networked warfare environments. The J-36's primary role remains a subject of debate among analysts. Some believe it is a 6th-generation fighter designed to maintain air superiority, while others argue it may serve as a regional bomber or a fighter-bomber hybrid, similar to the previously speculated JHXX platform. Its size and payload capacity support the latter hypothesis, suggesting a multi-role capability. Key features include its low observable stealth design, advanced sensors, and the ability to coordinate with unmanned systems. Analysts suggest the J-36 aligns with the 6th-generation system of systems approach, integrating with drones, other fighters, and air command systems to operate as a flying command ship or aerial destroyer in complex operations. The naval variant of the J-36, designed for carrier operations, could significantly enhance the Chinese Navy's air capabilities. Its advanced landing systems are tailored for operations at sea, potentially strengthening China's maritime influence in regions like the South China Sea and Western Pacific. The J-36's weapons suite is expected to include long-range air-to-air missiles, air-to-ground munitions, and potentially advanced laser weapons. Its internal weapons bays ensure stealth is maintained while carrying a diverse array of armaments. The J-36's emergence has sparked intense discussions among global military analysts and nations. U.S. Air Force Secretary Frank Kendall noted that the J-36's test flights were not surprising but emphasized their role in accelerating the U.S.'s Next-Generation Air Dominance (NGAD) program. Brian Clark of the Hudson Institute identified the J-36 as a primary competitor to NGAD, highlighting its potential to challenge U.S. air superiority. General Kenneth Wilsbach, commander of the U.S. Air Combat Command, warned that the J-36 and China's sixth-generation efforts could threaten U.S. dominance in the skies. However, confidence remains in NGAD's advanced capabilities to counter this challenge. Analysts have noted that China's aviation technology development is outpacing the U.S., with the J-36's test flight occurring before NGAD's public debut. European nations, including the UK, France, and Germany, are advancing their own sixth-generation programs, but they lag behind China's progress. In Asia, Japan's FX and India's Advanced Medium Combat Aircraft (AMCA) programs are also monitoring the J-36, though they require further development to compete effectively. The J-36's engines represent a significant challenge for China's military technology development. While WS-15 engines are currently in use, they require upgrades to meet the demands of a sixth-generation platform. The three-engine configuration may increase fuel consumption and maintenance complexity, posing logistical challenges. The aircraft's advanced software and sensor systems also face developmental hurdles. Integration with drones and other systems demands robust data sharing and real-time decision-making capabilities, requiring significant advancements in China's cyber and communication technologies. The stealth features, reliant on advanced materials and design, increase production costs and maintenance demands, necessitating efficient manufacturing processes for large-scale deployment. The J-36's emergence elevates China's position in the global military aviation competition, posing a challenge to the U.S. and its allies. It could shift the military balance in the Asia-Pacific, particularly with the naval variant enhancing China's maritime capabilities in the South China Sea and Western Pacific. China's sixth-generation advancements reflect its broader military modernization strategy and ambition to lead in global defense technology. The J-36's capabilities are comparable to those of U.S., Russian, and European sixth-generation programs, intensifying regional arms races, particularly in geopolitically sensitive areas like the South China Sea and Taiwan Strait. Furthermore, the J-36 could bolster China's defense exports, allowing it to supply advanced aircraft to allied nations, thereby expanding its influence in the global defense market. The J-36 is a cornerstone of China's military modernization strategy, aligning with the PLA's goal of becoming a world-class military by 2035. Its advanced technologies enhance China's air and naval capabilities while demonstrating integration with drones, cyber operations, and advanced weaponry. The development of the J-36 highlights China's technological innovation and research capabilities. The Chengdu Aircraft Corporation and other defense research institutions have made significant strides in design and production, supporting China's push for technological self-reliance. The Chengdu J-36 represents a landmark achievement in China's sixth-generation fighter development. Its unique tailless design, stealth capabilities, advanced engines, and integration with unmanned systems position it as a world-class platform. While its exact role and full capabilities remain unclear, requiring further testing and development, the J-36 underscores China's growing prominence in military aviation. The aircraft's emergence challenges the U.S. and its allies, potentially reshaping the military balance in the Asia-Pacific. Its naval variant could enhance China's maritime influence, while its advanced systems signal a new era of integrated warfare. However, overcoming technical challenges in engine development, software integration, and production will be critical to its success. The J-36's development showcases China's technological ambition and military leadership on the global stage. Its future deployment will provide further clarity on China's strategic intentions, but it already stands as a testament to its rapid advancements in defense technology.